Hello everyone, welcome back to the next lecture in the computer network series, and we are in the final part of the physical layer and media. Let's see the outcomes first. In today's session, we have 4 outcomes. Upon the completion of the session, the learner will be able to: outcome number 1, understand wired and wireless media. Outcome number 2, understand UTP and STP. Outcome number 3, we will compare copper media and fiber optic media. And the final outcome, we will know the popular wireless technologies. Let's start with the wired media. We know very well that a wired media will have a cable where the data between the nodes are going to be carried out using cables. We have a lot of wired technologies, and the popular wired media are copper cable, where in this copper cable we are focusing on an Ethernet cable. This copper Ethernet cable comes in 2 variations. Number 1, it can be an unshielded twisted pair cable. It is simply called as UTP, or it can be a shielded twisted pair cable. It is STP. Whenever I say STP here, it is shielded twisted pair cable. Very soon we will be seeing about a protocol called spanning tree protocol, and spanning tree protocol also is called as STP only. Whenever we say STP cable, it is shielded twisted pair cable. In this session, STP means shielded twisted pair cables. And we have copper coaxial cables as well, where this coaxial cable is mainly for audio communication and video communication, where we are not going to talk about this coaxial cable in this lecture. And the final cable that we would like to address is the fiber optic cable, which is very powerful. So we have copper Ethernet cable, copper coaxial cable, and fiber optic cable. We will start with the Ethernet cable, which is an example of a copper cable. This is an Ethernet cable which has connectors, 2 connectors. This is an RJ45 connector. Suppose we have a PC, that PC will definitely have an NIC card. If it is an Ethernet based NIC card, just take this cable, just take this port, insert it into the Ethernet port of the NIC card. Take the other side and insert it into the switch or the hub, so that your device will become a part of your local area network. Now when we see this cable, we don't know whether it is a UTP or an STP. That is, we don't know whether it is an unshielded twisted pair cable or a shielded twisted pair cable. But basically, Ethernet cables are twisted pair cables. Let me show you what is a twisted pair cable. We know that Ethernet has 2 variations. The single Ethernet cable, it can be an UTP or it can be an STP. When we just remove this portion and if we see, we know whether this cable is an UTP cable or an STP cable. Just go to this. After we open this section, we don't find any shielding here. So there is no shielding here. So this is an unshielded twisted pair cable. And this is an Ethernet cable only. And if we find any metallic shielding there, then it is a shielded twisted pair cable. The difference between a UTP and STP is that both are Ethernet cable only. The color code also, the color code of the cables or the wires are also the same. But in UTP, we will never find any shielding, whereas in STP, we will find shielding. This is a metallic shielding. Why do we need metallic shielding? This UTP cable is prone to electromagnetic interference and radio frequency interference. So data transmission can be affected because of these interferences. Electromagnetic interference or radio frequency interference will not have much impact in this data transmission using STP. Why? Because it has a metallic shielding and it protects the data transmission. If STP is very protective against EMI and RFI, that is electromagnetic interference and radio frequency interference, we can always prefer STP, right? But the problem is STP is costlier than UTP. Why? Because there is a metallic sheet and it is somewhat costlier than UTP. For a local area network which does not have much noise interference, we can go for UTP. So it is clear from this presentation that this UTP has some electromagnetic interference and radio frequency interference. Because of this interference, we will get a problem called crosstalk. We will see what is a crosstalk. In this UTP, if there is an electromagnetic interference or radio frequency interference, it affects the data transmission and it makes the data transmission affected with crosstalk. This UTP cable does not use shielding to counter the effects of EMI and RFI. And because of this, we will get crosstalk. Is there any way to counter the effects of crosstalk? We can just use STPs so that we can nullify the effects of EMI and RFI. If we don't have much money to purchase STP, then what can be done? There is a solution to counter the effect of crosstalk. And the solution is we can increase the number of twists in the wire. The negative effect of crosstalk can be limited by varying the number of twists per wire pair. For example, there are 4 pairs of wire, 8 wires, and there are 4 pairs of wire. If we increase the number of twists, for example, from here to here it is 10 centimeter cable. And if there are only 1, 2, 3 and 4 twists, if we increase the twists to 6 or 7 or 8, then the negative effect of crosstalk can be limited. So far we have seen STP and UTP. Now we will move on to the fiber optic media. In Ethernet cable, we know the data transmission takes place in the form of electrical signals, whereas in the fiber optic media, the data transmission takes place in the form of light waves. Since light is the fastest, then fiber optic cable is also the fastest mode of transmission. Fiber optic media has a high-speed transmission because the data are going to be carried out in the cable in the form of light waves. It's always good to compare copper cable and fiber optic cable. Let's have that comparison now. Copper versus fiber optic media. And there are some points for comparison. The first point in the comparison is the bandwidth. Bandwidth means how much data that can be transmitted. So copper media ranges between 10 Mbps, that is 10 megabits per second, to 10 gigabits per second. And fiber optic media ranges between 10 megabits per second up to 100 gigabits per second. So fiber optic media seems to be having the highest bandwidth when compared with copper. And the range is, it's relatively short, it's up to 100 meters, whereas it is relatively high in fiber optic media, it can range up to 100,000 meters. Copper media's range is up to 100 meters, fiber optic media's range is up to 100,000 meters. What about the immunity to electromagnetic interference and radio frequency interference? Since copper cables carries the data in the form of electrical signals, it has a very low immunity power. Whereas fiber optic cables has high immunity power, we can also say it is completely immune. So the electromagnetic interference and radio frequency interference will not disturb the fiber optic data transmission. Similarly, is there any immunity to electrical hazards? Copper cable has a very low immunity power when compared to the fiber optic cables, because fiber optic cable carries the data in the form of lights. Even if we are exposed to light for n number of days, we will not be affected because of that transmission. What about the cable cost and the connector cost? Copper cable is cheaper than fiber optic media. So the cost is lowest for copper and it is highest for fiber optic media. What about the installation skills? Do we need much skills? For copper cable, we don't need much installation skills to be known. Whereas for fiber optic media, we need to have some installation skills. What about the safety precautions? Safety precautions are very low in copper cable and it's very high in case of fiber optic media. And that's the comparison between the copper cable and the fiber optic media. So far we have dealt with the wired media. We will move on to the wireless media. In wireless media, we know that the data is transmitted in the form of waves and air is going to be the transmission medium. But there are always some drawbacks with the wireless medium. We will see what are the factors or the drawbacks of the wireless media. Wireless media has the following areas of concern. The coverage area. We have to choose the appropriate wireless technologies because the wireless technologies differ in terms of coverage area. For example, Bluetooth has a shorter coverage area than Wi-Fi and Wi-Fi has a shorter coverage area than cellular technologies, and cellular technologies has a shorter coverage area than satellite communication. So coverage area is an area of concern. We have interference because two or more radio waves can interfere with each other. So interference is the second area of concern. And finally, the security. As far as wired network is concerned, it is somewhat having better security than wireless network. Why? Because the data will be ultimately going through the cable or the wire. In wireless technologies, the data can't be unicast because if one node is sending the data, then all the nodes in the coverage area will be receiving the data. There is always a security concern with wireless media. So far we have seen wired media and wireless media. Let's have a look at the various wireless technologies. Wireless technologies. There are many wireless technologies and we will take the popular technologies like WiMAX, Bluetooth and Wi-Fi. There are still many wireless technologies like Zigbee, cellular technologies, satellite technologies. Let me focus only on these three aspects now and let's not go into the details of these things now. Let's have a very basic view about WiMAX, Bluetooth and Wi-Fi. WiMAX is also called as broadband services and its speed is up to 1 gigabits per second. Whereas Bluetooth, its speed is up to only 3 megabits per second and it can cater the need up to 100 meters. And coming to the Wi-Fi, it is commonly called as wireless fidelity and it is having so many variations and its speed varies based on the variations. So Bluetooth is having a very shorter range of communication than WiMAX and WiMAX has a very shorter range of communication than Wi-Fi. So there are popular wireless technologies which include WiMAX, Bluetooth and Wi-Fi. And that's it guys. We have understood wired media and wireless media. We understood UTP and STP and we compared copper media and fiber optic media and we know the popular wireless technologies. I hope the session is informative and thank you guys for watching.